Our next monitoring feature is called heating power. Heating power is a parameter that represents the amount of energy required to maintain the sensor temperature. If we think about the sensor on the skin, the sensor temperature is usually higher than the blood temperature, so any blood flow under the sensor site has a cooling effect. The amount of heating power necessary can depend on the local skin blood flow, and any heating power fluctuations may indicate changes in the local skin blood flow. For example, as blood flow increases and the cooling effect increases, the heating power will increase. Absolute heating power is the total electrical power needed to keep the sensor at 41 degrees Celsius. Depending on how your monitor is configured, AHP will be displayed at the bottom of the digital screen next to the sensor temperature. Relative heating power, or RHP, is the deviation from the stored AHP value. After the CO2 stabilizes, the monitor sets a reference value of 0. Throughout the rest of the monitoring period, any changes in the power needed to maintain the sensor temperature will be shown as positive or negative changes in RHP. To put this into context, RHP has a relationship with the patient's perfusion. An increase in the patient's perfusion will result in a positive increase in RHP, while a decrease in perfusion will result in a negative decrease in RHP. To further explain the relationship between perfusion and heating power, we have an example scenario where the patient's perfusion has increased since sensor application. Again, the sensor temperature is typically warmer than the patient's body temperature. When perfusion increases, the blood flow has a cooling effect on the sensor, meaning that the sensor requires more power to maintain the sensor temperature. This increase in absolute heating power is represented by an increase in RHP. Not only can we see increased RHP in situations where perfusion has increased, but also when the seal between the skin and the sensor is lost. If the sensor is dislodged slightly from the clip, it will be exposed to the cooler room air. The RHP will increase, and you will also notice a drop in your CO2 reading. In the opposite scenario, decreased patient perfusion will result in a decreased cooling effect. The sensor will not require as much power to maintain the set temperature, and this will be indicated in the decreased RHP. Let's take an example where the patient's RHP decreases to -30 and the CO2 acutely rises. The patient's assessment and ventilator settings have not changed, but you notice that the patient was repositioned and is now laying on the sensor. This external pressure has caused perfusion to decrease at the sensor site, which has caused RHP to decrease and the CO2 to increase. This can be resolved by positioning the sensor without pressure on the site. As mentioned before, the RHP reference is set automatically once the sensor stabilizes on the skin. RHP can also be set manually at any time. There are a few situations where the user should set a manual RHP reference. When the transcutaneous CO2 value correlates well with the arterial blood gas, when the RHP value has been unchanged, indicating that the perfusion may have changed since the sensor was first applied but is stable, or when applying the sensor to a new monitoring site without calibrating, which would normally reset the RHP reference. To set a manual reference, enter the Quick Access menu by pressing Enter. Then choose the second option, Set RHP Reference, and hit Enter again. How can we use RHP? Heating power can help clinicians identify whether a change in transcutaneous CO2 has occurred because of a change in blood flow or because of a change in the respiratory status. For example, if the RHP is stable but there is a large change in CO2, this change is likely reflective of a change in the patient's ventilation. If the RHP is unstable and there is a large change in the CO2, this change may be related to a change in perfusion at the measurement site. In both cases, it's important to first assess the patient and their respiratory status before troubleshooting the transcutaneous CO2 and RHP.